Alrighty. Hi guys, welcome to my video frequency calculations, what they mean and how we find them. The purpose of this video is to help you solve the problems on the last page of your collaboration assignment. The problems on the earlier pages were covered in my earlier video, gel electrophoresis and forensic profiling. So if you want to go figure out how to do the early pages of the forensic profiling assignment, go watch that video. This video is just responsible for covering this last page because it's kind of in its own league. So I wanted to have it in its own video here. So what we're going to be talking about in this video is frequency calculations. A frequency the reason why we're having you learn how to do frequency calculations is the whole point of forensic profiling is to try and identify someone in a crime. Right? We're trying to, we're taking a DNA sample from a crime scene, and then we're taking DNA samples from subjects, and we're seeing which alleles they have at an STR locus, and comparing them to the alleles held from the DNA from a crime scene to see who that DNA belongs to, right? Well, if I'm in court and I'm sitting there and I'm like a forensic investigator and I've got my little presentation up and I tell the judge and I say, well, see, the blood sample here matches my suspect here, right? They've got the same DNA, hence suspect is bad guy, put him in jail, right? And the judge looks at me and says, well, what are the odds you got the wrong guy? What are the chances that somebody else could match that DNA sample too? Because what are the, because if we got a guy that just happens to match the DNA, but really wasn't the guy that dropped off that DNA, we want to know, what are the odds you grabbed the wrong guy? Are the chances high that there's another person that could match this DNA? If so, then your evidence isn't conclusive. So we want to do calculations. These are statistical calculations that are predicting what are the chances there is another guy walking around somewhere in the world, or in New York City, for example. If I'm an investigator in New York City, what are the odds there's somebody else in New York City that matches this DNA too and could instead be the bad guy? So that's what we're asking here is, in order for my evidence, my forensic evidence to be conclusive, I have to show what the odds are that this actually does belong to that guy and not somebody else, okay? So that's the purpose behind doing frequency calculations, is I want to determine what are the odds that there's somebody else that could match that DNA from the crime scene. So here we go. So a frequency is how often something happens, right? In the case of this DNA story here, a frequency is basically what are the odds that if I grabbed a random person off the street, a random person, would have X, I'll fill in this gap here in a sec, would have this in the population. That'll make more sense here in a sec. This, or what goes in this box, is whatever type of frequency we're looking at. This is just whatever criteria we're looking for. They have to match whatever we're looking for here. So the first type of frequency, because there are three that we look at here, and each one is progressively more specific, harder to meet the criteria. The first type is called an allele frequency. An allele frequency is what are the odds that a random person in the population, if I grabbed a random person, what are the odds they would match one of the two alleles in that combination from the DNA sample, okay? So for example, if my DNA sample from the crime scene is a 9-9 or a 9, sure, yeah, a 9-9 combo. The allele frequency is what are the odds that if I grabbed a random person on the street and tested their DNA at this location, they would have at least 1 9 allele. Okay, that's what an allele frequency is the allele frequency of a 9 allele is what are the odds that if I grab a random person on the street, they will have at least 1 9 at that location. Okay, that's what an allele frequency is. And the odds someone will have that allele will have a certain allele in the population. Okay, so notice this isn't the odds of having a 9-9 combo. This is just the odds of what are the odds of them getting a 9. Now, to find an allele frequency is a really, really, really painstaking process. And if you want to figure out if you want to learn how that works, go watch my more complex video later. We do not expect you to ever calculate an allele frequency because you can't. It's a counting numbers game that takes a lot of time. So instead, to save you time, we give you these tables over here. Here's an example on your homework. We give you this little table where some scientists went and did all the work to figure out what the allele frequency was and then told you. Isn't that great? We love it when scientists do our work for us. So this is called an allele frequency table right here. What this shows is this says that at locus D16S539, that's just the name of the location, that's the address on the chromosome. At this location, 0.03 or 0.321, or if you were to turn that into a percentage, 32.1% of people have at least one 11 allele at the D16 locus. That's what that number means. Okay, so that's what that means. 0.321 or 32.1% of people have an 11 allele at D16. They just have to have any 11 allele. Okay, and what this number means right here is 0.018 or 1.8% of people have an 8 allele at D16. So notice, the bigger the number is, the more common that allele is in the population. Notice, and in this case, an 11 is more common than an 8 in the population. You're more likely to grab a person and have him have an 11 than an 8 because 32% is higher than 1.8%. You see that? So the bigger the number, the more common that allele is in the population, the more likely you are to find it. Okay. So that's how you know. I think one of your your prepare questions asks you to figure that out. That's how you would know what the most common allele is for that locus, the biggest decimal number, because the decimal number says what are the chances you'll find that one. And so the greater the number, the greater the chances. So that's what that means. And each column, notice this chart, so it's got all of the possible alleles down the left side here. And this chart has the frequencies for 3 different loci. So the odds of having a 10 allele at D16 is 0.056. The odds of having a 10 allele at D7 is 0.243. And the odds of having a 10 allele at D13 is 0.051. So notice you've got to keep track of which column you're in to make sure you're looking at the correct position. So when we calculate this, for example, Notice this says D7, so make sure you use only the D7 column, not these other two. Make sure you're looking at the right column. And we'll get to how to do that in a sec. I'm just familiarizing with you with this. You will never, ever, ever have to calculate an allele frequency. They will always be provided for you if you need them in a table, just like this, okay? And they're going to be given as decimal numbers like this. Okay, so that's an allele frequency. Is what are the odds if I grab a random person on the street, he will have this particular allele in his combo at that location, okay? All right. Let's pop back over here. The next level up, because notice, if I'm trying to prove to the judge that this is the bad guy, I say, well, this guy has a 10 in his combo at D16, and the DNA sample has a 10 at D16, and or an 11, sorry. So we say the sample has an 11, and the guy has an 11 in their combos, hence this belongs to him. And the judge is like, well, what are the odds somebody else has an 11 there? Well, 32% of the population. The judge is like, ha, 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 right? So we just, I mean, we figured out what are the odds, but that's not a very convincing argument. It's not very specific enough. It's very easy to have an 11 at that spot. So we need to make our criteria a little more stringent. Otherwise, this isn't going to be a very convincing argument. So that's why we're going to go to the next more specific level. This is a locus frequency. Okay, a locus frequency is the odds someone will have a certain allele combination in the population. The odds someone will have a certain allele combo or genotype, there's your vocab word there, in the population. Okay, what we mean by that is, whereas the allele frequency was, what are the odds they have a 9 somewhere in the combo? A locus frequency would be, for example, what are the odds they have a 9-11 combo at that location? Notice they have to have both numbers to meet the criteria. The odds of that happening are going to be smaller than just having one. It's kind of like if you've got a deck of 52 cards, an allele, just like your standard playing cards or whatnot, like poker cards. An allele frequency is, what are the odds if you draw a card off, it's going to be a heart, right? That's going to be 1 in 4, because a quarter of the deck is a heart, or heart cards, right? A locus frequency is more like, what are the odds you draw the queen of hearts? You got two, they have to meet both criteria. If you draw the king of hearts, it's not going to work. If you draw the queen of spades, it's not going to work. They have to meet both criteria in order to work. So the odds are going to be smaller. That's 1 in 52 now. So locus frequencies, we expect them to be smaller numbers, which is good, because the smaller the odds, the better the chances are that this guy really does belong to the DNA, because the odds are very slim of finding somebody else that has the same DNA he does, right? So that's good. We want smaller frequency numbers for proving to the judge that this DNA belongs to my bad guy, okay? So that's what a locus frequency is, where the allele, you only needed one of the numbers to match. Now with the locus, you need both of the numbers in the combo to match, okay? So this is going to be a smaller number than the allele frequencies were. So the way you calculate a locus frequency, this one has a little formula. Now, they teach you 2 different formulas here, and if you want to use those, you are welcome to. I find that people get confused with those ones because they accidentally use the wrong one. That's one of the most common mistakes I see on the exam, is students get the formulas backwards and they use the wrong formula, or they blend them together on accident and use the wrong formula and they get the wrong answer. So I developed my own version of the formula, And that's what I'm going to teach you here. And I'll show you that it's the same exact thing as those two formulas, but it's only one formula this time. So it's easier to remember and it applies to all situations. So let me teach you that formula and you're welcome to use it if you'd like, or you can use their formulas as well. Either way works. Here's my formula for how to solve a locus frequency. So I'll abbreviate locus frequency. I'll just say LF, locus frequency, is equal to A times P times Q. Okay, that's what I mean. That's my little formula here. A times P times Q, where A is equal to the number of different types of allele in the combo. I'll show you what I mean by that here in a sec. The number of different types of allele in the combo. So this number will always either be 1 or 2. It has to be one of those two numbers. It'll never be a decimal point. It has to be 1 or 2. And here's why. This is what I mean by this. If the person has a 9-9 combo at this location, how many different types of allele are there? Well, they only have one because both of them are the same. So they only have one type of allele. They have a 9 allele. That's one type of allele. So A for a 9-9 combo would be 1. A equals 1. If we have a 9-10 combo, they've got two different kinds of allele in their combo. A 9 is different from a 10. So A is equal to 2. So if the numbers in their combo are the same, if both of them are the same, they're homozygous. There's your vocab word for you. If both numbers are the same, then A is 1. If both numbers are different, A is 2. That's it. It's either 1 or 2. If they're the same, A is 1. If they're different, A is 2. Okay? That's what A is, the number of different kinds of allele in the combo. P is equal to the allele frequency, I'll abbreviate it AF. So the allele frequency from this table of the first allele in the combo. And Q is going to be the allele frequency, again, from the table, of the second allele in the combo. So let me show you an example here. Let's say I'm trying to find the allele frequency for the locus frequency for a person that has a, let's say, a 12-13 combo, or let's go 12-14. So at D16, so at my D16 locus, they have a 12-14 combo, okay? This is just an example. You're gonna have, for example, to solve this one for the locus frequency of D7, you'd have to go back to question 1 and find the combo of numbers that Maggie Mortis has at the D7 locus, and that's what her combo would be that you would use to solve the problem. I'm just using 12-14 as a combo. I'd have to go look at a gel, stuff like that to figure it out, okay? So you've got a 12-14 combo here. I'm trying to figure out what are the odds that someone would have a 12-14 combo in the population. So my formula is A times P times Q. A is the number of different types of allele in the combo. So let's look, how many different types do I have in the combo? Well, 12 is different from 14. So I've got two different numbers in the combo. So A is going to equal 2. P is the allele frequency of the first allele in the combo. So let's look. The first allele is a 12 at the D16 locus. So let's look at our table. We've got D16, 12 allele. So it looks like the allele frequency of having a 12 allele at the D16 locus is 0.326. So we'll write that in here. That's P. Okay. Now that's going to be times Q, which is the allele frequency of the second allele in the combo, which is a 14. So we come to our table because allele frequencies are found on the table. That's D16, 14 allele. So right there. So the allele frequency of the second allele in the combo of 14 is 0.020. Now, one thing that I have lots of students make mistakes on here. Notice P and Q are allele frequencies, not alleles. Let me say that again. P and Q are allele frequencies, not alleles. A common mistake students make is they go, okay, 2 times 12 times 14, because that's the first allele and that's the second allele. That will give you the wrong answer by a long shot. We're not putting the alleles in the formula. We're putting the allele frequencies of the alleles in the formula, okay? Do not make that mistake. It will mess you up completely. You have to make sure, if your P and Q are not decimal points, you're in trouble, okay? They should be decimal points. So P and Q are not the alleles themselves, they are the allele frequencies found from the table, okay? All right. There's my little speech there. Okay, so then to find the locus frequency, all you have to do is pull out your calculator. So let's bring this over here. Come on, calculator. Let's move. All right, there we go. So to figure out our locus frequency, got LF is equal to, okay, let me come to my calculator and I go 2 times 0.326 times 0.020 is equal to, and that is the locus frequency of having a 12-14 combo at D16, right there. So that would be my answer. Now notice, this is a really small decimal number. What this means is the odds of having a 12-14 combo at D16 are 1.3%. You know, that's a really small number, right? That's a really small number. That's much better than 0.326 that we were playing with earlier, right? It's much better to say there's 1% of the population has or could match this DNA sample, as opposed to 32% of the population could match this DNA sample. That's much more convincing. The problem is there's 7 billion people in the world, right? So basically we're still looking at 7 million people that could potentially be the bad guy. That's still not super good. It's better, but it's still not super good. So we want to go even more precise than a locus frequency if we're going to really convince the judge. Hence why we have to go the next level up. But that's how you calculate locus frequencies. So for this one right here, question number 3, and this one down here, question number 5, those two are having you calculate locus frequencies. And for those, you will use the A times P times Q formula to figure it out. Okay, that's how you'd solve 3 and 5. That's how you solve locus frequencies. It's A, P, Q. Okay. Let's go look at the next one up the chain. So we have to get even more specific here. The last one is called a profile frequency. A profile frequency is what are the odds that somebody will have a certain combination of alleles at multiple locations in their genome. Okay, the odds someone will have a certain combo of alleles at multiple locations. In other words, the criteria here is they have to have a certain combination at more than one loci. So they have to match me at 3 different places or more. For the purposes of our homework, they have to match them in 3 different places. Okay, so whereas a locus frequency was, so let's just to show you, here's our specificity here. An allele frequency was, what are the odds of having a 9 at D16? A locus frequency was, what are the odds of having like a 9-10 combo at D16? A profile frequency would be like, what are the odds of having a 9-10 at D16 and 8-9 at D7 and a 12-12 combo at D13? So notice, what for the profile frequency to work, they have to have this combo at that location, this combo at that location, and this combo at that location. They have to match all 3 combos in order to work. That means our odds are going to be way, 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 way lower. This is like getting 3 different decks of cards and saying, okay, what are the odds of drawing the Queen of Hearts off the top of that deck, the King of Hearts off the top of that deck, and the Jack of Hearts off of the top of that deck? The odds are going to be super, super small, which is good. That's what we want, right? The smaller the number, the more likely your bad guy is the bad guy. So let's show you how to calculate a profile frequency. Let's see. Let's keep that one, okay? So a profile frequency, I'll abbreviate it PF. PF. Profile frequency is calculated by finding the locus frequency of the first combo times the locus frequency of the second combo times the locus frequency of the third combo. Okay, so these take a little bit of math, because remember, how did you find a locus frequency? Well, locus frequency was equal to A times P times Q. So what you're going to do is do A times P times Q on a 9-10 combo at D16. You're going to find the locus frequency for having a 9-10 at D16. Then you're going to find the locus frequency. So again, you're going to do A times P times Q. So that will give you a number, right? You'll have the locus frequency here. Then you'll do it again, but for an 8-9 combo at D7. So you're going to do APQ for an 8-9 combo there, and you're going to come out with a locus frequency here. Then you're going to do it again for the locus frequency of having a 12-12 combo at D13. And that will give you a number. Then you're going to multiply them together, because there's locus frequency 1, there's locus frequency 2, there's locus frequency 3. So you're going to find the locus frequencies of each of these 3 combos and then multiply them together, and that will be your profile frequency. Okay, so there's a few steps to this. So let's work through this example here. Okay, so let's find the profile frequency of a person that has a 9-10 at D16, an 8-9 combo at D7, and a 12-12 combo at D13, okay? So here we go. First, we have to calculate the locus frequency of having a 9-10 at D16, okay? So for D16, my locus frequency is equal to, so we're at D16 right here. Make sure you're looking at the right column. Looking at a 9-10 combo. So there's my 9. So notice the two numbers are different. So A is going to equal 2 times, let's see, so the allele frequency for 9 at D16 is going to be 0.113. Times the allele frequency of having a 10 allele at D16. So let's go look here. There's my 10 allele at D16. Okay. That's 0.056. 0.056. So the locus frequency of having a 9-10 combo at D16 is 2 times 0.113 times 0.056. Okay, so the locus frequency for D16 is 0.012656, according to my calculator. Okay, so that's number 1. We just found locus frequency 1. Now let's go do D7. At the D7 locus, my example guy has an 8-9 combo. Okay, let's close this back down here. Okay, so let's go look at the D7 set here. So we're looking at D7. Make sure you're looking at the correct column here. We have an 8-9 combo. So the odds of having it, so we've got A, so 8 and 9 are different. So the locus frequency, A is going to be 2, because 8 and 9 are 2 different numbers, times P, which is the odds of having an 8. So there's my 8, there's my D7. It's right there, 0.151. Times Q, which is the odds of having a 9 at D7. So there's a 9. We've got 0.177. Sorry, I messed that up there. 0.177. So we multiply those together using the calculator. Two times 0.151 times 0.177. You wind up with, so there's my locus frequency for having an 8-9 combo at D7. Zero, 5, 3, 4, 5, 4. Okay. Now D13. So that's my second locus frequency. Now we have to go find my third locus frequency. Okay. So we at D13, he has a 12-12 combo. So A, so we've got locus frequency equals A. A is the number of different numbers. They only have one kind of number here in their combo. They only have 12. So A is going to be 1 times P, which is the odds of having the first allele in the combo. So that's a 12 at D13. So D13, 12. They've got a 0.248. And then the odds of having the second number, which is also a 12 at D13. So that's going to be the same number, 0.248. So my locus frequency is going to be 1 times 0.248 times 0.248 is equal to 0.061504. Okay, so there's my 3 locus frequencies. There's locus frequency 1, there's locus frequency 2, there's locus frequency 3. So now we have to calculate the profile frequency. Okay, we're going to the next step. Calculate the profile frequency. You take locus frequency 1, multiply it by locus frequency 2, multiplied by locus frequency 3. So we're just going to take these 3 locus frequencies and multiply them together. So our profile frequency will be locus frequency 1, which is 0.012656. I got that from over here. We calculated that. Times locus frequency 2, which is 0.053454 times locus frequency 3, which is 0.061504. Okay, let's run that through a calculator here. You've got 0.012656 times 0.053454 times 0.061504. There's my profile frequency. Now notice, if you know anything about math here, this is a really, really, really small number. Right here, we've got and that 4 looks like a really big number, but this e to the -5, that's the same thing. That's calculator talk for times 10 to the 5th, or to the -5th. What that means is you actually have to take the decimal point 5 spots this way. So it would actually be 0.0000416, etc. That's my profile frequency. So profile frequency is equal to 0.0000416, etc. I'll just round it to 416. Notice that's a really small number. The odds of having that, of matching the DNA at all 3 spots are really, really small. So if my bad guy does match the DNA at all 3 spots, it's most likely him. Because the odds of finding somebody else in the world are really, 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 really small. So that's why we do profile frequencies. So there you go. So you're going to have to do this type of calculation for problems 4 and 6. Because if we scroll down here, 4 is a profile frequency for suspect 2. 6 is a profile frequency for father B. So you're going to have to go back and look at the earlier problems and find out what their combos are at each of the 3 loci. And then calculate the locus frequency for those combos at each of the 3 loci. And then multiply those 3 locus frequencies together. That's how you'll solve those 2 profile frequency ones. So there you go. That's how you solve frequency calculations. If you need, or if you have any questions, please feel free to reach out to me or your professor. feel free to set up a tutoring appointment with me. I'm happy to answer any questions that you have. And good luck. Thanks for watching.